This is Dr. Maria Uria with a solution to HAP 725, Week 3, Question 7. For this question, we are to use the likelihood ratios provided and calculate the probability of mortality for the cases that are described in the case file. We are then to list the 20 patients with the highest probability of mortality, where the highest probability of mortality will be listed first. The first step is to open Python and import the pandas and NumPy libraries. We're going to then read the likelihood ratio file into Python. And then line 76 indicates the number of rows and columns that are in the likelihood ratio data frame. In this case, we have over 24,000 records and 7 columns. Since the case file is a CSV file, we're going to use the read_CSV function to read the data into the case file data frame. Line 77 then indicates the number of rows and columns that are in the case file data frame. We have 378 rows of data and 4 columns. We don't need to use all the columns from the case file data frame. Line 159 shows how to create a new data frame with the desired columns. Next, we use the case file with the limited columns to determine the unique counts resulting from grouping by ID and ICD-9 combinations. The column names are then renamed. Note that the EdgeRDX column has been renamed to RDX. In step 5, we're exploring the group 3 data frame. You could skip this step, but it's a good idea to understand what kind of data you're working with. So for line 189, what we're doing there is showing the number of rows of data that are in each of the columns. Line 174 then shows the number of rows and columns that are in the group 3 data frame. Line 186 shows the unique values found in each of the group 3 data frame by using the .nUnique function, which is similar to the select distinct query that you can run when you use SQL. The code in line 92 and line 176 will display the names of the columns from each data frame. In line 177, we create a new data frame using the merge function. We merge the group 3 and likelihood ratio data frames. The output on line 177 shows the resulting merged data frame, and it has the first 3 columns coming from the group 3 data frame. In addition, the ICD-9 and the RDX columns appear once in the merged data frame. Since they are identical columns found in both the likelihood ratio file and the group 3 data frames, which I've indicated in the green or black squares. In line 180, we fine-tune the merge data using the merge function and the left join on the ICD-9 and RDX columns. The left join is indicated by using how equals left. In step 8, we begin our probability calculations. We begin by finding the log values of the likelihood ratio for each ID and ICD-9 combination. In this step, we find the sum of the log for each patient grouped by patient ID and log of likelihood ratio. The results are entered into a new data frame. We then find the odds for each patient ID. In this final step, we are determining the probability as shown on this slide. The probability is then sorted using the sort_values function. The results show only 4 patients have the highest probability of mortality, and the probability is listed in descending